Well, because South Carolina, our number one crop is a chicken. So why am I talking about container media? And here's there we go. Besides chickens and pine trees, we also have a very large ornamental production uh, sector. A lot of woody ornamentals, azaleas. If you buy azaleas up here, they may be produced in South Carolina. And so that's why we looked at this, and in particular, things related to woody ornamentals. So composted poultry litter. I'm going to be very specific on this. I'm talking about a stable compost product. In this case, it was broiler breeder litter mixed with hay and some cotton gin trash and some other carbon sources that I don't know what they are, but it's a truly stabilized and cured product. Okay. And like I say, common carbon sources are wood shavings, sawdust, gin trash is the big one in our neck of the woods because we do have cotton gins. And what my hort people, especially in particular my ornamental people, are interested in are both sets of physical and chemical properties. And the chemical properties, the nutrient type things we're used to dealing with. But the new thing for us was things like water holding capacity, aeration porosity, the dry bulk density, and things like that. So we set up ways to measure that. And of course, the major and minor nutrients, EC5 is a measure of salinity, organic matter, and those kinds of things. So I worked with a guy named Bob Polumsky. He's our arborist. And so the bark and sand mixtures, and there's very many different ones. And so we got with Bob and said, what's a typical mix we should work with? And we came up with bark and sand and 8 parts screen pine bark to 1 part sand. And then from that, they've got to add amendments like peat moss, vermiculite, sphagnum moss to adjust these physical properties, mainly water holding capacity and aeration porosity. There we go. So there's a couple of disadvantages of this mix. First of all, there's a lot of bioavailable carbon in that pine bark, and that creates a mobilization of nitrogen. It also is very acidic. Now, so for some of our woody ornamentals, that's fine. We need acidic conditions. Others need more basic. But we're looking at a pH of 5. We need 5.5 to 6.4 in most of our mixes. But also, the things to modify the physical properties are non-renewable and quite expensive. And so we're basically looking for something as an alternative. And actually, one of the goals of using the composted poultry litter is to, hey, can we basically supply some or all of these non-renewable products and eliminate their need? So previous horticulturalists have done work and they've shown putting various amounts of compost did have positive benefits on the production, but there was nothing on how do you come up with a blend? What do you decide on to come up with, how much compost can you put in? Do I have to worry about salinity? Do I have to worry about nutrients? What do I have to worry about? So that's really what we're after. So the topics that we're going to briefly summarize are some characteristics of the poultry litter that we used, also the screen pine bark, because that's our 2 main ingredients that have nutrients. We're going to summarize the benefits on these physical properties, and then we're going to compare what we got with fertilized base mixes. Something we didn't realize when we started this was you start out with a base mix. Well, you got to fertilize the base mix before you ever pot up a plant. And that's really what we're trying to improve and basically replace some of the needs for those things. Now, I'm not going to go through the methods, but this is in the proceedings paper. You can go click on a link to this and you can see all the gory details that you might want to see that I'm not going to talk about this morning. I don't know why this doesn't like that. So first thing, let's compare these characteristics. Now, if we look at the pine bark and the CPL, that's the composted poultry litter. These are on percent dry basis. You can obviously see you got a good bit of organic nitrogen. Obviously, the composted poultry litter is kind of winning in most of these. Nitrogen, carbon, nitrogen, not carbon, organic nitrogen, but also the C to N. So you look at that pine bark, and we did 2 samples. So I'm showing you a range. Call it 150 to 160 to 1. Tremendous immobilizer of nitrogen. And this composted litter was 9.2. That's going to actually help us a little bit. Same with phosphorus and potash and key secondary and minors. Significant amounts of composted poultry litter. None of us are surprised by that. And we also looked at several of the other minor nutrients. I put sodium in red. That is the biggest sort of actual sodium in this mix as well. Now, a couple other characteristics. We noted pH. Actually, we had a range of 4.6 to 5.1, the pine bark. Composted poultry litter was 7.33. Now I have some that'll be 8, some other types of compost. Sand's about 7. From a salinity standpoint, we're well below what, we're not in the concern range at all. Looked at moisture, the VSTS says, yes, we really have clean sand, and we do have basically a lot of carbon that's not been worked on. And then density is something we care about, because basically if you've got a large yard of containers and they blow over, you create a lot of work. So density, they don't want the thing to tip over. So we're obviously, the litter's helping, the sand's the biggest piece of that. We can keep moving on it. So what are the benefits on these of adding composted poultry litter to these physical properties? That's what we're looking at here. We looked at 3 blends. Well, kind of like our controls, the base mix, doing nothing. Then we put in 20% composted poultry litter. We're doing this on a volume basis, 40% and 60%. So here's the basic results. Now, green means it's in the range. So if I got the range, the desirable range from the literature is 10 to 20% on aeration porosity. 18 going down is good. So as we increase the percentage of poultry litter, we increased aeration porosity. Water holding capacity wasn't quite as dramatic. We want to be 45 to 65. Kind of like the best one was 40% CPL. pH, we actually, for this particular compost, by going 20 to 40%, we got right in the pH range that we wanted to be. 6.5 is red because we rarely, 6.4 is like where they stop, okay? And then, of course, we increase the bulk density. So one of the most unexpected results was, we figured when we started this, we got to be worrying about nitrogen, salinity, all these other things. Guess what? The number one parameter to look at to figure out how much compost to put in a media is pH. You've got to have the pH right, or it's not going to work. And so if I'm thinking about growing azaleas, I'm like 20 plus. Maybe I can go 30%. I can go do the calculation. Really, a weighted mean gets you there pretty darn quick. So that makes it kind of easy. Make sure you got your pH right. And some compost will have a higher pH. Okay. Some will be lower. So it's not going to be the same as this one, but pH is the key thing and that we looked at. So we've already run through that, but we did improve the bulk density and pH. We got everything, all of our blends got in the range we wanted. Now, does this mean this is perfect for every media? No. Each grower is going to have their little thing they want. All we're saying is, if we getting in the ballpark, we can play with the whole idea is you adjust it to get really what you want. So can compost reduce the addition of non-renewables and some lime? Yes. Now, we did something else. Water holding capacity is on a volume basis. I really like to know how much mass of water there is. And we did a quick experiment with pots. And we did, there's a paper we did on dairy manure compost where we did the fancier moisture release curves. But I want to try just something quick and dirty, where we bring the pot to saturation. Look how much water, how many grams of water per pot, day 1. And then we just let it dry in the lab and say, which one held the most water? Now, obviously I could go fancier, but it gave me a mass idea pretty quick. And that's what we're after. And so 20, 40, and 60, basically at saturation, we went from 8 to 34% actual mass of water per pot. And after 4 days, we're still 12 to 31%. We're hanging on to it pretty well. Putting a plant's going to change some things, but a simple media like this, I think we pretty much see what we need to. So we compared some fertilized mixes. This is something, again, we didn't know what people did. Went in the literature, and it's all over the map. Everybody's got their thing. But about 3 to 8 pounds of granulated triple 14 osmocote per cubic yard of base mix. That's a common range. There's some people who do outside that, but Most are in that range. So we had information about the the uh, uh, the fertilizer, and then basically we used our bulk density to get to a volumetric nutrient content. We also had to estimate availability of the nitrogen and the availability of phosphorus. Short answer is the phosphorus from the pine bark is not worth anything. Dr. Franklin figured that out. And so he did an availability about 40% for the compost, 100% for the fertilizer. And so this is the range. We went through this. I want to note right here the bottom line. When I go out and fertilize these mixes, I go from a negative pan, if I didn't do anything, so I got positive 0.29, 1.09. These are pounds per yard cubed, pounds of nutrient per yard cubed. Same with the phosphorus. I got available phosphorus, much less than what's in there. And of course, we got contributions from the pine bark for the miners. That's nothing new. Get to the right place. So I just used 20 and 40 in this comparison. Why? Because I'm kicking out 60 because it gives me too high a pH. But notice I made a big difference, and what I really care about is C to N. I dropped it to 43 and 24 to 1, and I have positive available nitrogen. This is my base mix, and I'm going to fertilize on top of this as I grow plants. What's the trick? Somebody tell me. There we go. Of course, the minor nutrients, the compost, bump them up quite substantially. So can compost be used to reduce this fertilizer? The answer is yes. And it'll vary with the kind of compost we have. So now additional fertilizer is also used. They'll use small nursery. They'll take little scoops of pellets and put on. If you're fancier, you do fertigation. But this improves C to N. We also expect we should have some reduced nitrogen losses from the pot. We didn't measure that, but it's all pointing in that direction. So we've concluded that this is probably the best marketable use for compost because I'm getting many points of value, reduce or eliminate the need for the expensive ingredients to modify properties, either reduce or eliminate lime for pH adjustment, even if I reduce it substantially, improve water retention of that media, reduce the need to use commercial fertilizer, and basically I won't be buying any minor nutrients if I do this.